Hi guys, we're going to take a look at this question where we have a crate. There's our little crate with a mass of 25 kgs that is sliding down this plane that has an incline of 15 degrees to the horizontal. During the first part of motion, A to B, there's no friction. As you can see, they clearly made it a bit smooth for us to see that there's no friction there. But then from B to C, we can see clearly there's a little rough patch there. So there has to be friction. 5.1. Draw a free body diagram. So free, we know it's just the dot of all forces acting on the crate while it moves from B to C. Okay. So 5.1, our free body diagram, that is our crate of 25 kgs. When it moves through B to C, so let's just say the crate is here. I'm just going to draw it here for you guys. So let's say the crate is moving from B to C. What are the forces acting on it? It will definitely be, let me just get my mouse, definitely be weight, right? Please use a ruler for this, guys. Friction would be pulling it back up, and definitely then the normal force. All right, if you want to look at it, I'm going to draw a slope here for you guys. If you want to look at it like that, you can clearly see that's how it should look like, right? There will be the slope, there will be the crate, you see, going up. The normal force will be perpendicular to the box, and then the weight. I can even draw it for you guys here so you can clearly see it. Do you see that? So now I can see it better, right? So it's essentially what we are just drawing there. Okay, 5.2. Calculate the magnitude of the acceleration of the crate while it moves from A to B. So they want the acceleration while it moves from A to B. All right, so I'm just going to do 5.2 over here. So we got to use our Fnet formula. So right here, the forces acting on here, there's no friction, there's weight, and there's an incline. All right, so we can use Fg sine theta equals to ma. Then we take the weight of the box is 25, or the mass of the box is 25. Gravitational force is 9.8, and our theta is 15, and that will be 25a. We do our little calculator magic there and our math magic, and we get our acceleration to be 2,54 meters per second squared. So it's 2,54. 5.3. Write on the direction of the acceleration of the crate while it slows down from B to C. Write only up or down the slope. So it will be up the slope, the acceleration. 5.4. The magnitude of the net acceleration from B to C is 1.2 meters per second squared. Right? Calculate the magnitude of the frictional force acting on the crate. Okay. So I'm just going to clear the screen. So we're going to look at 5.4. I've just cleared the screen so I can have some space to write. 5.4. So we have our usual formula that we'll probably get a mark for. What is our net force? Do we see that we have the block is here? We have to look at the block that is running down here now. The block is here. It has been moving downwards. And there we have our parallel forces in play. Fg parallel. And we also have our friction. So our parallel forces will be 25 times 9.8 times sine of 15 minus the friction, because that's what they want. And 25 times the acceleration, which is 1.2. And we do our math magic and we get friction to be 93,41 newtons. Easy as pie. And that's it, guys. See ya.